Hey everyone, today we're pulling back the curtain on one of the most powerful ideas in all of technology, object-oriented programming. It's kind of the invisible blueprint for the digital world you live in every single day. So, let's dive in. So, let me ask you a quick question. What could a video game character, your online bank account, and your social media profile possibly have in common? They seem totally different, right? Well, they're all digital objects, and they're all built using the exact same core idea. And by the end of this, you're going to see exactly how. But, to really appreciate why this concept was such a game changer, we have to take a quick trip back in time. We need to see what the world of programming looked like before objects came along and brought some serious order to the chaos. Imagine trying to build a massive skyscraper, but with no blueprints. That's pretty much what building big software used to be like. As programs got bigger, the code just became this tangled, chaotic mess. It was a nightmare to manage, a headache to update, and almost impossible to grow. Something had to change. And this was the solution. It was a total shift in thinking. Instead of writing these long, confusing lists of instructions, developers thought, hey, what if we just modeled our code after the real world? They started creating these little digital objects that could represent things we all get, like a student, a car, or a bank account. And suddenly, things started making a whole lot more sense. So how does this actually work in practice? Well, the entire concept really boils down to one simple but super powerful analogy. If you get this one thing, you've pretty much got the core of OOP. It's all about the blueprint versus the car. And this slide lays it out perfectly. On one side, you've got the class. Think of this as the blueprint. It's just the plan, the design, the template. It doesn't do anything by itself. Then on the other side, you've got the object. That's the actual car you build from the blueprint. It's the real thing. And the best part? From that one single blueprint, you can create thousands of unique individual cars. So let's make it official. A class is just that blueprint. Let's say we were designing a student class. The blueprint would say, okay, every student is going to need a name and an age, and every student needs to be able to do something, like study function. It's just the plan. And the object? Well, that's the real deal. It's a specific, tangible thing. It's not just the idea of a student, it's the actual student, John, who is 20 years old. It's a real thing that now exists in the computer's memory, built directly from our student class blueprint. Okay, so what exactly do we put in one of these blueprints? Well, a class really only defines two kinds of things about an object: what the object is and what the object can do. First up, you've got attributes. The easiest way to think about these, they're the nouns. They're the data, the characteristics that describe the object. So for a car object, attributes would be its color, its model, its current speed. For a bank account, it'd be the account number and the balance. Simple as that. And second, you have behaviors. You might also hear these called methods. If attributes are the nouns, then behaviors are the verbs. They define all the actions that the object can actually perform. So a car object can drive or brake. A bank account object can deposit money or check balance. This is the part that brings the object to life. Okay, so we've got our blueprint, the class, and it describes all the attributes and behaviors. Great, but how do we actually, build the car? How do we create a real object from that plan? Well, this is where the digital factory comes into play. So how does this factory get turned on? Well, in most programming languages, there's a special little keyword, and it's usually new. Think of this word as the big green start button on the factory floor. When the computer sees this command, it grabs the class blueprint and gets to work, building a brand new object right there in its memory. Let's just look at how this works in a real line of code. It might look a little technical, but it's really just a simple three-step instruction. First, student S1, we just create a label for a new object so we can find it later. Second, we hit that new keyword. That tells the factory to start building. And third, student parentheses runs a special setup method that gives the object all its starting values. And boom, just like that, an object is born. Now we finally get to the really good part, the big payoff. Why on earth do we go through all this trouble? Because it lets us model incredibly complex, real-world systems in a way that's actually organized and manageable. The blueprints are reusable, which saves just an enormous amount of time and effort. Just take a look at this bank account blueprint. It's perfectly clear, right? You've got attributes for the data, like the account number and the balance, and you've got behaviors for the actions, like depositing and withdrawing. Now, from this one single blueprint, a bank can create thousands, even millions of individual bank account objects. And if they ever need to change the rules for how withdrawal works, they just change it in one place, the blueprint. So, here's the bottom line, the crucial point of all this. Object-oriented programming isn't just about writing code. It's really a way of thinking. It lets us take the messy, complex, real world and organize it into clean, logical, and reusable digital pieces. And that is what makes building everything from massive banking systems to your favorite video games even possible. So the next time you post a photo or play a song or add something to your online shopping cart, just stop and think about the blueprint that must be behind it. What attributes does it have? What can it do? You'll start to see that pretty much everything in your digital world is built on these simple, powerful ideas.